Okay, I have an interesting problem. We've got a function here. G of x is sine of x minus a plus cosine x plus a. A is a fixed number, okay? When I see a problem like this, it's a good idea to go to Desmos, I would say, and just put that in. You make a slider, and then this will give you some intuition on what's happening. You play around with values of a. All right. Then, of course, we have to do it rigorously. Let's take a look at an illustration. Okay, so there's a function, and I'm going to run it. Okay, first, to get the period, there's a number of ways, I think, to do this. Since you're taking calculus, I thought of taking the calculus route. So if we can find basically the distance from one maximum to another, or it could be from one minimum to another minimum, that distance will be the period. Okay, so let's see what happens with this function as a changes. Okay, see there's a point there where it reflects on the y-axis, on the x-axis, okay. All right, now let's look at the function, and I'm going to use the angle difference formula here and the angle addition formula here to do some simplifying. So that's the two identities. A little bit of rearranging. You should do this on paper, by the way. Check my work. That's just rearranging some pieces. We notice here that you can factor it out. Okay, cosine A minus sine A is a constant, right? So that can be factored out. Just for simplicity, I'm going to rename that constant to k. All right. So there's the function. And so I can find the critical points with the derivative. So let's do that. Derivative looks like that. Set it equal to 0. Solve for x. They are equal. Okay, in the first quadrant at pi over 4. Second quadrant, 5 pi over 4. And every pi, so we're just adding pi, and it goes on. Okay. So to get the period, we can take the difference. It alternates, by the way. It goes max, min, max. Or it could go min, max, min. We'll talk about that later. But basically, if I go from pi over 4 to 9 pi over 4, that's the period. So this, if that constant is greater than 0, then those are maximums, and if it's less than 0, they're minimums, actually. So the period is the difference to pi. Okay. Now part B. We want to look at it when a is equal to pi over 4. All right. Go back to our original simplified function. Okay, pi over 4. Cosine of pi over 4 is equal to the sine of pi over 4, right? 45-degree angle. That's 0. And so the function is just a straight line at y equals 0. Horizontal line. You can see as you run it through different a's that it flattens out and it actually approaches the x-axis. Okay, so when a is pi over 4, it's a straight line. Okay, now let's look, let's just pause a little bit. Sorry. Back that up. Okay, now I'm looking at that, remember the constant k. Okay, so the constant k was cosine a minus sine a. Okay, here it's positive. And just watch when it goes negative, it's going to reflect on the x-axis. Okay. And this is also multiplied by the function. So this is like the amplitude, right? So it's k gets bigger and then it flips. Okay, so it's like an amplitude. All right. And the last part, back to the function. So again, I'm just to simplify, I'm going to make that k. K is a constant. So it only affects the amplitude, as we saw. So if k is less than 0, that constant is less than 0. It's reflected, okay? It's a negative amplitude. Okay, and I think that basically is it. So yeah, I recommend going to Desmos as a good way to get intuition for this. Yeah, hope that was helpful.